doing homework corrections from the homework I gave yesterday. So, been asked to go over part E and part G. Fazil, आप बताओ homework में कोई problems?
नहीं मिस कोई इशू नहीं.
Okay, ठीक है. I'm going to do E quickly. E is y equals ln cos q 2x. All right. So we start with differentiating ln fx. And what's the derivative of that? Because this 3 is not on the entire function. It's just on cos. So we can't start with fx power n's derivative. Instead, we're going to take the derivative of ln fx, which is 1 over fx times f prime x. So it's going to be 1 over cos cube 2x times derivative of cos cube 2x. What is that going to be? How do I derivate cos cube 2x? Cos cube 2x. इसकी derivation कर. अब power rule use होगा. Power rule is 3 comes down and then it becomes cos 2x square. And then we have to derivate what's inside the bracket. It's cos 2x. Derivative of cos 2x is minus sine 2x. And that's not all. We have to derivate 2x again, which is going to be 2. So f prime x is 6. In fact, minus 6 sine 2x and then cos square 2x. Okay. So what does that give us? We get a minus sign in the numerator and a sine 2x in the numerator. Cos square and cos cube cancel out and we just get a cos in the denominator. So that's how we get minus 6 tan 2x. ठीक है आदम?
Yes, ma'am.
All right, part G. Part G is y equals 5 e power sine square x. Okay. 5 is going to stay the same. It's the coefficient, constant coefficient. Okay. And what is the derivative of e power fx? It is e power fx times f prime x, the derivative of fx. 5 is 5. The derivative of e sine square x is e sine square x, but then we have to derivate this with it. So times the derivative of sine square x would be, first we'll apply the power rule, 2 sine x power 1, and then we have to derivate the fx again, which is going to be cos x. So we're getting 10 cos x sine x e sine square x. ठीक है आदम?
जी मिस क्लियर.
All right. Okay. Moving on, we're going to discuss the derivative of tan inverse x today. So let's call it case, which case were we on? Case 3, let's call it case 4, which is derivative of tan inverse x. Now derivative of tan inverse x is 1 upon 1 plus x squared. And the derivative of tan inverse fx is 1 upon 1 plus fx whole square times f prime x. You just find questions on tan inverse. Here they are. Okay. So the first question is, y equals tan inverse 3x. Find dy over dx. So we're going to use this formula, 1 upon 1 plus fx whole square multiplied by the derivative of fx, which is 3. So we get 3 upon 1 plus 9x squared. Part 2. Part 2 is tan inverse 2x plus 3. Same formula. It's going to be, the derivative of this is going to be 1 upon 1 plus fx, which is 2x plus 3 whole square, times the derivative of 2x plus 3, which is just 2. So 2 upon 1 plus 2x plus 3 whole square. You may further expand the brackets or you may not, it's fine. Unless the question says give your answer in a particular form, you can just leave your answer like this. Okay. Next is tan inverse x upon 7. Okay. The same formula, tan inverse fx, derivative of which is 1 upon 1 plus fx whole square times the derivative of x upon 7. The derivative of x upon 7 is 1 by 7. So I'm getting 1 by 7 in the numerator, and in the denominator, I'm getting 1 plus x square upon 49. This can be further simplified, so I'll do that. There's 1 over 7 in the numerator, and in the denominator, it's 49 plus x square upon 49. So we have double fractions. We can write it as 1 by 7 times 49 upon 49 plus x square. So it becomes 7 over 49 plus x squared. Any questions so far? Okay. Next would be पता नहीं कौन सा नंबर चल रहा है, I've lost count. Tan inverse 3x plus 2 over 4. Okay. So again, it's tan inverse fx, and once we derivate that, we get 1 upon 1 plus fx whole square. So fx here is 3x plus 2 upon 4. And then we also have to multiply the result with the derivative of this. What's the derivative of 3x plus 2 over 4? 3x plus 2 over 4 is actually just 3 over 4x plus half. So the derivative of this is just 3 over 4. So 3 over 4, writing that as a single fraction, 3 by 4 upon, there's a 16 in the denominator, and then we have 16 plus 3x plus 2 whole square. Okay. So we have 3 by 4 times 16 upon 16 plus 3x plus 2 whole square. And then this becomes 4. So there's 12 in the numerator and 16 plus 3x plus 2 whole square. Okay. I think that's enough practice for tan inverse effects. That's case 4. We'll keep coming back to it as we do the other cases, cases 5, 6, etc. So let's do a chain rule question on this case, case 3, and the case we did yesterday. And then a stationary point question on case 3. Okay. So, question is, if x decreases at a constant rate of two radians per second, where y equals x minus sine x. Find the rate of change of y when x is equals to pi by 3. If x decreases at the constant rate of 2 radians per second, that means this is dx over dt, which is minus 2, since it says decreases. So you must write a negative sign with it. And we're given y equals x minus sine x. From here you can find dy upon dx, which would be 1 minus cos x. Then it says find the rate of change of y. So we have to find dy over dx, sorry, dy over dt. And x is given pi by 3. So I'm starting with dy over dt. Dy over dt would be equals to dy here, something in the denominator, something in the numerator, and dt here. And that something is dx and dx in this question. So dy over dx is 1 minus cos x, and dx over dt is minus 2. Now x is given, which is pi by 3. Substitute that. So that is going to give us minus 1. Let me just confirm. Set settings to radians. 1 minus cos pi by 3 times minus 2, minus 1. Yes, that's correct. Any questions here? If not, then we move on. The second question is, there's a figure given to you. Let's draw the figure first. This is A, which is A comma 0. That's B, which is 0 comma B. And this is X, which is 1 comma 8. All right. So the question is, in the figure, the line segment AB passes through the point 1 comma 8. ये तो figure में ही नजर आ रहा है. और फिर it is also given theta here. So I'm not mentioning that from the question. They're mentioning the points, they're mentioning the angles. Show that AB equals 1 over cos x plus, just give me a second. Okay. 1 over cos x plus 8 over sine x. So it's not x, it's theta. 1 over cos theta plus 8 over sine. Okay. So how do we show that AB is equals to that? Look at AB, the length AB in the diagram. This is AB, and AB can be written as AX plus XB. Now let's take a look at AX only. This part only. So AX has a theta here. And what is this length? That's going to be This length is going to be, the height is 8. That's going to be 8. And this length is going to be what? We don't need this length, in fact. We don't need this length. We just need AX in terms of theta. So we can use sine. So sine theta equals 8 upon AX. So AX equals 8 upon sine theta. So that's what I'm writing here. AX is 8 upon sine theta. Then we have to find XB. Okay. XB would be, let me draw XB here. So this is X, this is B. From corresponding angles, this is going to be theta as well. This would be theta as well from corresponding angles. Remember, if we get an F-type shape, if this is theta, then this is theta as well. So that's theta here as well. That's theta. And this distance here from origin to X is 1. So this is 1. And we need to find XB. So I'm going to use, if I need to find XB, I'm going to use cos. Cos theta is equals to 1 over Bx. So Bx equals 1 over cos theta. So replace Bx with 1 over cos. So we've shown that Ax equals 8 over sine theta plus 1 over cos. Okay. That was the first part of the question that show that AB is equals to this. Second part is find the least value of AB. That's the first part. A. Second part B is find least value of AB. Okay. Least value means minimum value. At the minimum value or the maximum value, we know that the derivative is equals to 0 because that's the stationary value. So in part B, what do you have to do? You have to derivate this AB and then you have to equate the result to 0. So instead of AB, can I write, it's a distance. So I'm just going to write X. Instead of AB, I'm writing X equals 1 over cos theta plus 8 over sine theta. Let's derivate this and the variable at the right hand side, okay, chalo, let's just keep it as AB. This is the distance AB. Okay. Derivate this distance AB with respect to theta because the variable at the right hand side is theta. And whatever is the result equated to 0 because at the minimum point, the derivative is 0 or at the maximum point, the derivative is 0. Maximum point in a graph looks like this. At this point, derivative is 0. And minimum point looks like this. Here also derivative is 0. So we have to find the derivative of 1 over cos theta plus 8 over sine theta. Instead of that, I'm going to instead write it like this. Cos theta comes up, becomes cos theta whole power minus 1. And then plus 8 sine theta whole power minus 1. Okay, now let's derivate this. Minus 1 comes down. Power of cos is now minus 2. And derivate cos theta again, that would be minus sine theta. Okay. Then the minus 1 comes down and it becomes minus 8. power of sine theta is now -2. And then the derivative of sine theta gets multiplied, which is cos theta. And we equate all of this to 0. So we're getting sine theta upon cos square theta, and then -8 cos theta upon sine square theta. Let me check if it's correct so far. Yes, it is correct so far. All right, now let's take LCM. So LCM is cos square theta times sine square theta. It's going to be sine cube theta -8 cos cube theta equals to 0. Okay. The denominator becomes 0 when it goes to the right hand side. So we're only left with sine cube theta -8 cos cube theta equals to 0. So rearrange, we get sine cube theta equals 8 cos cube theta. When you have sine on one side and cos on the other side, you can change it into tan by dividing sine cube with cos cube. So we get tan cube theta equals to 8. Now, solve this and get the values of theta. Okay. This would mean that tan theta is equals to 2. Let's find alpha. Okay. So remember, whenever we're solving a question on trigonometry and the question does not mention degrees in specific, you have to find your answer in radians. Right? So set the calculator to radians. Let's find alpha here. It's going to be tan inverse 2, which is 1.10714. Tan is positive in the first quadrant. Add sugar to, and in the third quadrant, 1.10714, 1.10714. I think the question mentions that the angle is acute. It doesn't mention that the angle is acute. However, the figure is given to us in the question. And in the figure, yeah, I think I've cleared the figure. And in the figure, it's very obvious that theta is an acute value. इस तरह की figure है ना, यहाँ पे theta. So it's acute. So you only have to take the answer in the first quadrant. So that answer would be this value, which is just 1.11 in 3 significant figures. Next thing we need to discuss is product rule. And I suggest कल करते हैं product rule and quotient rule. And your homework for today is revise all the cases we've done so far. Because I keep telling you that पिछले cases अच्छी तरह नहीं आएंगे तो अगले cases भी नहीं आएंगे. ठीक है? So before we start product rule and quotient rule, make sure you've revised all these cases very well. ठीक है? बाकी कल करते हैं इंशाल्लाह. Take care guys. आज की क्लास थोड़ी छोटी थी. I'll see you tomorrow. Allah Hafiz.